is up, gamers? So today we're going to be talking about something called center of mass. So center of mass is a kind of a difficult concept and is usually split between 2 days. Right? This video should only supplement your education, right? It's to prepare for the AP exam, so I'm assuming you have some basis of knowledge of this, so we're just going to review what this stuff is. Yeah, so let's get into this. Okay, so we want to find the center of mass of the system. Let's say we had a mass of, this marker is bad. Let's say we had a mass of 50 kilograms on the left side and a mass of 50 kilograms on the right side. Right, so we got 50 kilograms, right? And then we connect it to another 50 kilograms. Well, conceptually the center of mass would just be right here, right? Right halfway between. Let's keep that in mind. And now let's consider some different things, right? Now let's consider the actual formula in order to find center of mass. So the formula says you pick a starting point. It doesn't matter what starting point. Most commonly your starting point might be all the way to the left. So I'm going to say my starting point is right here. Then if your masses are points, right? So in this case my masses are technically points, right? Because they're only, it's as if this 50 kilograms was like right here, and this 50 kilograms was right here. The volume doesn't exist, right? There's no distribution. Imagine this is just a particle that's 50 kilograms right here, and same right here. Well, then what you do is you just take your mass times your distance, right? So the formula is equal to the sum of all the masses times the distances to your starting point, right? So I'll say starting point P. This R would be our distance from mass 1 to my starting point P, right? You sum all of these together, and then you divide by the total amount of mass. And this is going to, if we do some unit analysis, right? This is mass, so it's going to be kilograms times meters divided by mass, which is kilograms, and our units are going to end up in meters, right? So we're going to get some distance, and that distance is going to be our center of mass. So let's just plug in that formula for this. This 50 kilograms is right where my point is. Let's imagine my point is like right here. I don't want to draw it there because we'll mess it up. Right? So my point is right here. 50 kilograms is exactly 0 distance away. So I would say 0, right? And then remember kilograms times meters is my unit, so right? Plus this, right? So let's say this is some distance L, right? So plus L multiplied by 50 kilograms, right? And that's all our masses, right? We have this mass, assume this thing is massless. Then we got to divide by our total mass, which is just 50 plus 50 kilograms, so 100 kilograms. Now if we divide the top and bottom, right, this stuff doesn't matter. We get L times 50 over 100. And what do we get? We get L over 2. Well, that just told us our center of mass is exactly halfway between these two masses, which conceptually makes sense. And that is what matters. It conceptually makes sense, right? If we can find a conceptual example to help us ground this equation, then we've done something. All right, that's cool. Next, what we're going to do is we're going to talk about some more special things about center of mass. So now let's imagine that instead of having a massless pole, right, our pole suddenly has mass. Let's say it's this pole has a mass of 25 kilograms, and it's equally distributed about the whole thing. So I will draw it as a thick boy to show that it has mass. Alright, so here's 25 kilograms, right? I still got my 50 kg. I still got my 50 kg. Right? Well, this is a bit harder, right? This is not a mass, or sorry, this is not a point mass, right? We assumed these are point masses, but we know this mass is evenly distributed about the entire pole. So it's not a single point, but it's distributed about a whole pole, right? So we have to do something else. What is that something else? Well, something to know, this is very important, right? That all this mass is actually just going to act on the center of mass. So let's start with a more conceptual example. Let's say I had a ball, right? And it was going through a projectile motion, so it's going to go in a parabolic shape. But suddenly, at this point, the ball explodes. Assume all energy is conserved. what happens? Well, some pieces will go here, some pieces will go here, some pieces will go here. But if we watch the path of all three of them, if we watch the path of the center of mass, right, the center of all three of these masses, which is about like right here, it will still go in the parabolic arc. Forces always act on the center of mass, right? So even though forces are going to act here, here, and here, it's as if we consider all three of these things a system. This is the center of mass. The force will just be acting on that center of mass. That's the same with this, right? So let's say that we had 25 kg. Well, clearly the center of mass would be right in the middle of the pole, right? The center of mass is right in the middle of the pole because it's evenly distributed, so we just need to go halfway. Okay, so on both sides we'll have 12.5 kg. Here, at this point, we can assume that this point itself has 25 kilograms, and then we ignore the mass of everything else. I don't care about the pole anymore. I know the center of the mass of the pole is exactly halfway in the pole. Alright, knowing that information, let's use our formula again. Right? Our formula is very important to remember, is the sum of m, I, r, I. Oh, I wrote it wrong, didn't I? Right? For all I different, for all the different masses, right? So we want to sum every single mass in the system divided by the sum of all the masses in the system. So I'll start with this one, right? Again, I'll start right here, right on the left side, so I get 0, right? 0 kilogram meters, because I'm 0 meters away from this mass. I am, alright, if this length is L over 2, right? Or sorry, is L, right? Then we said halfway between the pole, right? Halfway between the pole is our center of mass of this pole, right? Not the center of mass of the whole system, just the center of mass is 25 kilogram pole. So the next mass to consider would be the pole. And we just have to add L over 2 multiplied by 25 kilograms. Right, that's our distance. It's L divided by 2, right? Halfway times our mass, 25 kilograms, plus L times 50 kg. Yeah, because this 50 kg is still L distance away. Now we've got to divide everything by 50 plus 25 plus 50, so that's 125 kilograms. Alright, so now if we sum everything, or if we do everything together, what do we get? Well, we get L times 50 plus 25 over 2, so that's around like a number, so 62.5, right, kg, divided by 125 kilograms. Well, 62.5 divided by 125 is exactly equal to 1/2. So we get L 1/2. Again, center of mass exactly halfway between. Conceptually, this makes sense, right? If we have different values, we're going to see a different trend, right? So I won't calculate them, but I will tell you where these center of masses are. Right? So let's say that we have, something here that's a mass 3. And then a non-mass thing, and then something here is mass 1. Well, the center of mass is actually just L over 4, right? If this distance is L, the center of mass is, if this is L, the center of mass is L over 4. You don't need to know how to find this, right? We had our equation. You already can plug it in, and you can solve for it, and that's all that's necessary, right? Because AP test probably wants to see your steps anyways. You'll get dog points if you don't show them. But what's important is that we conceptually realize L over 4, right? This center of mass is going to be closer to where there's more mass. If I had like 50 here, and then I only had 1 here, the center of mass is going to be super close. The more massive one end is compared to the other, the more close that center of mass is going to be to that, that thing with more mass. Okay. So that was the brief introduction to center of mass. Next time we're going to be talking about, I guess, the differential way to do it, the physics-y way to do it. So have fun, yay!